All right, so properties of normal distribution. This is 13.4 for us. It was 7.1 for another class. So as before, we had before, I just go to the old set of notes that I had. It didn't make sense to rewrite it. I had it sitting there. We could just talk through it. So 13.4 is properties of normal distribution. Probability distribution function, sometimes called PDF, is an equation used to compute the probabilities of continuous random variables. It must satisfy the following two properties. The total area under the graph must equal to 1. Make sure you hold on to that because we're going to use that key. The total area under the graph is equal to 1, and the height of the graph must be greater than or equal to 0 for all possible values. The main thing that we're going to use in this is that this statement right here. That's what's going to keep popping up. So give you a chance to write that down. All right, a continuous random variable is normally distributed or has a normal probability distribution if its relative frequency histogram has the shape of the normal curve. And we've talked about that normal curve before. On a bell-shaped curve, it's symmetric about your mean. In other words, the mean is in the middle, and what goes on the left side of the mean goes on the right side as well. Let's see something. Yes, you can. Someone asked, could they use calculator or notes on the final? Yes, that'll be fine. I'll give you more details about final. I'll try to get an email out to you guys today, this evening. But yeah, you'll be able to use whatever you have at your disposal. All right, so we have also what we call inflection points. And that's where the concavity of your graph changes from concave up. That's what I have right here, to concave down. And that's okay, that's what I said right there. Points on the curve where the curvature of the graph changes, the concavity. That's when you add a standard deviation and then subtract the standard deviation from the mean. That's what those symbols are. Right here in the middle is your mean. And then if you add a standard deviation, that's an inflection point. And then if you subtract the standard deviation, that's another inflection point. Going back to your final exam, we will not meet in person. I know somebody asked me that class in my previous class. We will not meet in person. We still will meet through Blackboard Collaborate. And you just have to make sure that you enable your camera so that I can see you, and bring your ID so that I can confirm that it's you. And then we'll take the test. All right, properties of the normal density curve. The normal curve is symmetric about the mean. I mentioned that already. And then the second one, I see a question. Let me know, is that how far you wanted me to go back up? Final exam. I think that's what you asked. You said what day is it? It is the day before Thanksgiving, actually. Day before Thanksgiving. So, not a problem, not a problem. All right, Miss Golston, are we good to go? Or did I go up good enough, far enough, I should say? Okay, great. All right, so properties of the normal density curve. That second point is that the mean is equal to the median, which is equal to the mode. It has a single peak or highest point at your mean or your average. Remember, we saw that going back here. Highest point is right here at the mean in the middle. That's what they're talking about. We already mentioned number 3, is that it has inflection points at adding a standard deviation and subtracting a standard deviation from the mean. The area under the curve is equal to 1. So if you had a marker or data value that was right here, all right. So we have a data value that's right here. If 0.7 is to the right of it, that means 0.3 will be to the left of it. Because everything under the curve, and we're talking about under the curve, everything under here is equal to 1. So if you know what's to the left of something, that means you know what's to the right of it as well. You just subtract it from 1, or vice versa. Number 5, the area under the curve to the right of the mean equals to half, or in other words, 0.5. And the same goes for the left of the mean. So this goes back to what we were saying as far as it being symmetric, and everything under the curve is equal to 1. All right. As x increases, the graph approaches but never reaches the horizontal axis, which is 0. Same goes for x decreasing. So that's why when you look right here, I don't let the graph touch the actual horizontal axis. That's why there's that space right here. Space right here. Because it's not supposed to actually touch. Because it never touches 0. I think this is the last one. Yep. All right, last one. The empirical rule says that approximately 68% of the area under the curve is within 1 standard deviation of the mean. Approximately 95% of your data or the area under the curve is within 2 standard deviations of the mean. And approximately 99.7% of the area under the curve is within 3 standard deviations of the mean. we'll talk about what that means in a second. All right. So just generic, this is the graph that matches the empirical rule. So in other words, we're going to have our mean in the middle. If I were to add a standard deviation and subtract the standard deviation, that gives me 68% of my data. 34 and 34, it gives me 68. Oh, well, I got it down here. I don't have to keep scrolling up. It's right down here. And then also, if I were to add and subtract or go out two standard deviations, that's 95% of my data. You add 13.5, 34, 34, and 13.5. If I were to add another standard deviation, a third standard deviation, and subtract the third standard deviation, that will give me 99.7% of my data. So those percentages will always stay the same. At 0.15, 2.35, 13.5, and 34 on both sides of your mean, they will always stay the same. Now the numbers on bottom will change according to what is your mean and what is your standard deviation. But those percentages will always stay the same. Good. You know if I need to come back down. All right, so let's put that into action and see how this works. I think this is it for this section. Yep. So let me erase some of the stuff first, and then we'll walk through it. Yeah, I guess I erase all that. All right, so let's look at this problem. The birth weights of full-term babies are normally distributed with mean of 3,400 grams and standard deviation of 505 grams. I don't think I had a question on this. I just wanted to, just show you guys how it works. So the next one, I think the next one we actually have, actual questions on it. So notice they give us the mean here and the standard deviation here. So if I wanted to apply the empirical rule, once again, those percentages in the middle, not in the middle, those percentages stay the same. There you go. Before I go there, I'll just do the numbers. Do it like this. So you have your mean in the middle, which is 3,400. And there's a right side of your mean and your left side of your mean. So you're talking about 3,400 plus one standard deviation That'd be 3905. Then for the second one, 3400 times, not times, but plus 2 standard deviations. 4410. And then 3400 plus 3 standard deviations. 4915. So all you have to do is keep adding 505 to the standard deviation, do it 3 different times. That'll give you your 3 numbers to the right of your mean. That's 3905, 4410, 4915. All right. Now, so for the left side, we'll do the opposite. You're going to subtract the standard deviation 3 different times. Any questions on the right side, though? Good. So here we have 3400 minus the 505. Oh, 34. 2895. Let me see something real quick. 34, not 44. Okay. And then 3400 minus 2 times standard deviation. It's 2395. Or 2390, excuse me. And then subtract it one more time. That would be 1885. All right. So that's how your chart would look. So questions on the calculations before I discuss more on what that means for us. All right. So if we go and look at it as far as the empirical rule is set up, that means 34% is in between these values right here. 13.5 here, 2.35, 0.15. Like I said, those percentages stay the same. Just the numbers on the bottom will change according to what information you have. So what that means is that in between 2895 and 3400, there's 34%. So in other words, there's a 34% chance that the full-term baby will weigh between 2,895 grams and 3,400 grams. That's what this stuff means. So if you want to know what's the percentage or what's the chance that a baby would be in between 3905 and 4915, you would add these 2 percentage chunks together. The chance of a baby weighing more than 4915 would just be 0.1, but it would be 15%. I mean, not 15%, 0.15%. The chance of a baby weighing less, a full-term baby weighing less than the 1885 would be a 0.15%. So that's how you would use the empirical rule and the percentages that they have set up. Questions. right, so let's go to the rest of the notes. Hold on, let me see something. Yep, so this is doing the empirical rule again, but this time we have actual questions that are applied to it. So we have a survey of 1,000 U.S. gas stations. They found that the price charged for a gallon of regular gas could be closely approximated by a normal distribution, with a mean of $3.10, standard deviation of 18 cents. How many stations charge? And they give us an A, B, and C. So I'll let you copy that first before we go into A, B, and C. All right, are we good? Are we good? Let me know. I'll go back down. All right, so we're at A. How many stations charge between $2.74 and $3.46 for a gallon of regular gas? So we do what we did in the last example. Establish or we recognize what our mean and standard deviation are. So it's $3.10 and 18 cents. And we can find the right side of our empirical rule chart by adding the standard deviation to the mean 3 different times. So that's what I did here from my right side. Added 18 cents to the 310, gave me 328. Added 18 cents again, gave me 346. And added 18 cents one more time, gave me 364. And to get the left side, subtract. Subtract the 18 cents 3 different times. So the first one gave me 392, second one, do it a second time, gives me 274, and then do it a third time, gives you 256. Let me know if you have any questions before we keep going. All right, scrolling up. And so this would be our empirical chart, empirical rule chart. You know, we got our 310 in the middle, which is our mean. Right side, 328, 346, and 364. Left side, 292, 274, 256. Once again, notice our percentages are the same. That's your empirical rule. Those stay the same. It's the numbers on bottom that change according to the information that you had. All right, so going to our question, we want to know what was the percentage of gas stations, or how many gas stations charge 274, between 274 and 346. So 274 is right here, 346 is right here. So if you add up all of your percentages between 274 and 346, you get 95%. So that's what I have here. Percentage of gas stations between 274 and 346 is 95%. The question asks, though, for the number of gas stations, not the percentage. So in order to get that, you just multiply that percentage to the total number of gas stations. And remember, the total number of gas stations is 1,000. So I give you a chance to write that, and then we'll finish off that problem. All right, so that means you're going to take 95% multiplied to 1,000. Don't forget to convert your percentage to a decimal before you do your multiplication. So that's 0.95 times 1,000. And that means there will be 950 gas stations that would charge in between those two rates. All right. Questions before we look at B? All right. So this time they want us to charge. How many gas stations will charge? Yeah, how many gas stations will charge less than 328? So what we can do is just add all the percentages that are less than or to the left of 328. So when we look at 328, that's right here. So all the values that's to the left of it, all the percentages that are to the left of it. So you're talking about this 0.15, 230, 2.35, 13.5, 34, and 34. So I add up those right here, and that gave me 84%. So we take that 84%, multiply it to the 1,000, and that's 840. All right. Next one's more than 346. So if we go back to our chart, 346 is right here. We're talking about more than. So it'll be to the right of the 346. So you add up the percentages that are to the right of the 346. That's 235 and 0.15, which is 2.5%. All right. So multiply that 0.025 to 1,000. Give me 25 gas stations that will charge. greater than 346. All right. Got one more thing to talk about in this section, then we'll be done with it. All right, so let's look at normal distribution. So what we're going to use are what we call z-scores. And z-scores represent the distance the data value is from the mean or average in terms of standard deviations. All right, so examples of that, if my z-score is 1.23, it represents the data value, or says that the data value is 1.23 standard deviations above the mean. Negative 0.78 is saying that the data value is 0.78 standard deviations below the mean. So whether it's above or below, this means that it's positive versus being negative. So if it's positive, that means it's that many standard deviations above the mean. If it's negative, it's that many standard deviations below the mean. All right. All right, so we have a z-score chart, and I'll show you that in a second. And I'll also be looking to send you a copy of that. Your z-score chart is the one that I'm going to show you how to use is going to be different than the one that's actually in the book. To me, the one that's in the book is kind of it's a little more involved, a little harder to read versus the one that I have that I want to give you. So now you still can use the one in the book; it'll still give you the same answers. Just that this one that I have is a little easier. If you look up z-score charts, all of them aren't set up the same, even if you were to Google them. So I'm gonna show you how to read this one. The one that I have, that I'll show you is set up this way. It starts at negative 3.4, ends in positive 3.4 on the left column. And on the top row, it goes from 0.00 to 0.09. So the way you'll do this is that if you have, let's say, this z-score right here of 1.23, on that left column, you'll look for 1.2, and then the top row, you look for 0.3. So you look for 1.2 over here, and then 0.03 up here. And where they meet will be the data value that you'll get from the chart. All right. So once again, this is your z-score. 1.2 is the first part that will be what's on the left column, and the 0.03 will be what's on the right. I mean, not on the right, excuse me, will be what's up top. And then where they meet at inside the chart is the value that you will take from the chart. So let me pull it up real quick. Give me a second. Thought I had it up. All right, so this is one side. Notice it goes from 0 on this left column. You have 0 up here, and then it goes 3, 4. And then the other one, okay, why is it not sharing? Taking a long time. One, two. Can you guys hear me? Because my Blackboard collaborator stopped responding. All right, so I'm back. I got kicked out. Good stuff, right? So let's try sharing that screen again. This Blackboard collaborator is the best. All right, so let's go back here. It's supposed to be still recording, so hopefully it's doing that. So 1.2 is right here, and then the 0.3 is right here, and where it meets is right here at 0.8907. Same thing as if I had let's say 0.48. 0.4 would be right here, then I would go all the way over here to 0.8, and that value will be 0.6844. All right. Any questions on how we would read it? All right. So 1.23 is going to give us a yield the chart value of 0.8907. Let's talk about what that means. All right. So this chart, if you would have saw, when you look at the top of the chart, it gives you this diagram. Just let you know that whatever chart value that you have is always giving you the less than or what's to the left of your z-score. And what's to the left of is always going to represent less than. If you look at the regular number line, generic number line, if I look at -1, what's less than it will be to the left of it. What's greater than it will always be to the right of it. Same thing if I were to look at +2, what's less than it will always be to the left of it, and what's greater than it will always be to the right of it. So that's what we mean by less than or to the left of. So that z-score of 1.23 represents a data value. So 0.8907, or in other words, 89.07% of the data is less than this data value. That's what the chart's telling us. 89.07% of the data is less than that data value. And remember, we talked about the relationship of what's under the curve, or how much data value we have. That's a number, that's everything totals to 1. So if I know what's to the left of it, then I also know what's to the right of it. So I have that 0.8907. If I want to know what's greater than it or to the right of it, I can subtract it from 1. And that's what I did in that second statement. 10.93% of your data will be greater than the data value. So the chart automatically gives you less than. To find greater than, you have to subtract it from 1. All right. So the way we will calculate our z-scores or find our z-scores is that we will take the data value that's in question, subtract the mean, then divide by standard deviation. All right, I believe this is the last example, so this is it. Yep. All right, so once again, to calculate your z-scores, we're going to take the data value minus the mean, divide by the standard deviation. So soda machine dispenses soda into 12-ounce cups. Tests show that the actual amount of soda dispensed is normally distributed with a mean of 11.5 ounces and standard deviation of 0.2 ounces. Let's write that before we go to A. All right. So A is what percentage or what percent of cups will receive less than 11.25 ounces of soda. So we want to convert 11.25 to a z-score. That's the first thing we want to do. So they have 11.5 as our mean, 0.2 as our standard deviation, and the data value in question is 11.25. So remember, it's the data value minus the mean divided by the standard deviation. And so here are the symbols for that. But even if you don't remember the symbols, just remember it's your data value, which is at 11.25, minus the mean, which is 11.5, divided by your standard deviation, which is 0.2. And that would be negative 1.25. And always round your z-score to 2 decimal places. Didn't mention that before, but always want to round to 2 decimal places. Now, once you get your z-score, you go to the chart. And I would go and go to the chart, but I just got kicked out, so I want to risk that again. So what you would do is go to the left column for negative 1.2, and then to the top row for 0.05. And they will meet at 0.1056. So we are looking for less than. Remember that the chart gives us less than. So we can use that chart value. That means that 10.56% of the cups will receive less than 11.25 ounces of soda. And that 11.25 was our data value. All right. B is what percent of cups will receive more than 11.8 ounces of soda. So we follow the same procedure. We take 11.8 and convert it to a z-score. So that'd be 11.8 minus 11.5 divided by 0.2. All right. So now we go to the chart. We have 0.50. And the chart, we have 1.5 on that left column and 0.00 on the top row. And they meet at 0.9332. All right. So the chart gives us less than, don't forget that, but we need more than. So we're going to subtract the chart value from 1. Because remember, if we know what's to the left of the chart of the z-score, we can figure out what's to the right by subtracting it from 1. Everything under the curve is equal to 1. So 1 minus that 0.9332 is 0.0668. So that means 6.68% of the cups will receive more than 11.8 ounces. And of course, Weber sign will let you know if they want 2 decimal places or not. One decimal place, they'll let you know. So make sure you pay attention to those directions. All right, got one more. Questions on anything so far? Some questions may not come up until you actually, get in there. So I understand that as well. All right. Last one. What percent cups will receive between 11.2 and 11.55 ounces of soda? So this time we're looking at between two different values. We need to find the z-score for each one of them individually. So the mean and standard deviation is still the same. They're going to stay the same, but we need to, and I call one value x1, call the other one x2, find the z-score of each one of them individually. All right, so first z-score, 1 for 11.2 is negative 1.5. The second z-score, 1 for 11.55 will give us 0.25. So we need the data in between the first z-score and the second z-score. That's what we're looking for. Go to the chart of each one of them individually. You get 0.0668 for the first one, and then 0.5987 for that second one. So to get or to find between, we'll subtract the two chart values. Notice we're not subtracting z-scores, we're subtracting the chart values. So it's 5987 minus 0.668. And that will give us 0.5319. So this means 53.19% of the cups will receive between 11.2 ounces and 11.55 ounces of soda. All right. Questions on anything? Very good, very straight. All right, so to just sum it up, we have these three scenarios. Less than, when you go to the chart, you're going to use the chart value that's given. If it asks for more than, subtract the chart value from 1. In between, you'll subtract the two chart values from each other. So less than and more than, there'll be keywords or phrases. They may say exactly less than or more than, or they could say for less than, below, shorter, colder, anything that suggests less than would fit that phrasing. And more than, say greater than, could say hotter, taller, above. Those would, lend towards you doing more than and following that procedure. Those are your only three scenarios that could occur. All right. Questions, concerns, comments? Okay. So try this stuff out. See if you get stuck. From this point forward, we will be reviewing. Make sure you pay attention to your emails. I gotta write another note to myself. You have your reasoning test that we talked about before. I don't believe it's going to be practice. Anyway, you'll get instructions on everything. That's your reasoning test. You have your final exam that's coming up. Chapter 13's test needs to be posted. And so I'm going to give you this chart. So you have some emails that's going to be coming from me. So make sure you pay attention to them. And if you need help, feel free to hit me up. Or You can't wait till the next class because remember, this 13.4 is our last piece of new information. So from this point forward, we will be reviewing. So you really, unless you just want to meet separately, you don't necessarily have to. You can wait for class, and I will, just be answering questions during class time from this point forward. So whatever makes you more comfortable, fine with me, and we'll go from there. So if questions are generated over the weekend, next class will be the opportunity to answer them and make sure you're straight and have clarity. All right. Questions or concerns before we close out? Anybody? All right. You guys have a great weekend. Be safe. Hopefully this thing take everything before I got kicked out and after. If not, I recorded it from my last class as well, so that will be available to you also. Outside of that, you guys have a great weekend, and I will see you next week.